Hello, everybody, and welcome to this week's webinar. My name is Alex Rafanos. I'm an application engineer here at Rize. We have Kirill, who's going to be monitoring the chat. So if you guys have any questions during this webinar, please feel free to ask in the chat. We'll have time at the end to address all of those. We also have Prashant with us as well, who's also an applications engineer. And we will be discussing health and safety today. And kind of the thing that I want to address with this is more of a story. Tell the story of not only how safe 3D printing is important for people that are using printers. As you can see, I have the Rize behind me here. Over on the other side of my basement, we're in my home. The other side of the basement, we have the 2XC as well, printing at the same time. Really just to emphasize the fact that, you know, safety with 3D printing is something that not everyone takes into consideration right away. And it's a big part of our talk today, not just on how Rize is really pioneering that for the 3D printing industry, but really discussing it for almost any industry, really focused on FDM and kind of color 3D printing. So that's where our talk today is going to focus. To start, I'll tell you a little bit about myself so we can let some more people get into the chat, and so you can know more of the context of where my perspective comes from. I've been using hobbyist level 3D printers for about 5 years now. So I have a Prusa i3 Mark II.5, I have a Creality CR10, and an XYZ printing DaVinci Pro. I also have a rigid bot bake. So I'm well versed in this type of 3D printing. And back 5 years ago, there was not a lot of discussion about emissions and really how safe all of this was. And as an engineer, it was really just a tinkering thing for me, but I was doing it out of my home. And back then, back in the old world before the pandemic and everything that's happening in today's world, that was really not something you really thought about. And it was only with materials that smelled a lot like ABS, is one of my first projects here, that you really noticed that there was anything going wrong. And so we'll discuss the research that's come out today and really why Rize is, why I'm comfortable having this in my basement while I'm talking to you, not having any PPE. But it also relates to just overall safety from all the process of the 3D printing, right? Which it's not just the process of the actual extrusion of the plastic or the color deposition. It's an entire thing about how are you able to be safe and healthy when you're 3D printing in it? Have we really even thought about all these different areas? So there's 4 main areas we're going to focus on today. The first one is the printing process we talked about already. It's the extrusion of plastic. What kind of emissions are there, not only from a particulate standpoint, but from the actual release that's happening. We'll discuss more on that and the differentiator of Rize. Post-processing is another process of having your 3D printed part and using 3D printed technology. We'll show the differences between Rize and FDM and the different ways that we're able to make sure that you're safe as not only an operator, but as a company and just as people 3D printing. And then there's obviously the actual usage of the part, right? That's ultimately why anyone's buying a 3D printer, is to use the parts that are being printed. But how safe can you be with those parts once they're actually printed, and what other things you can do is, and we obviously have stories of kind of the current world right now, especially with the COVID situation, which we'll talk about. And then, of course, at the end is what happens once you've used your part. What does your part's end of life look like? Is it one use and you drop it? Are there other ways that you can extend the life of your part? And we'll discuss that here. So first, we have to talk about the printing process. This is, I think, where most people think about with safety for 3D printing. And there's a lot of questions that pop up. You know, can I safely be next to my 3D printer while it's working? I feel comfortable with the Rize here and the 2XC running at the same time. We will pepper in all the reasons why Rize is pioneering this and why I am comfortable with this. We'll do that throughout the whole presentation. We also have a part that we will remove the supports at the end of this. So if you want to stay on for the end of that during the Q&A, I'll show you how the supports work on that. But more questions that you ask, are there additional PPE needed? It's one of the hidden costs of 3D printing when people first buy a 3D printer is, you know, okay, well, how safe are we actually being? Are there extra things that are needed to actually run this and make it work? If you're using a powder-based system, Obviously, there is a large amount of environmental controls and PPE that are needed, which is in the kind of the color game, especially. Do HEPA filters work? This is something in the early days, people were putting HEPA filters on printers, hoping to completely make the whole printing process safe, but we'll talk more about that in the research and how Rize differentiates itself. Would you be comfortable 3D printing in my home? As you guys know, we're in my home, we're in my basement, so welcome. But otherwise, would I be safe doing this? Would you be safe as an employee having one of a 3D printer in your home in the way that the world has changed and how businesses have to adapt? And we're going to talk about some of these things right now, specifically the person operating this, the people that are involved in the process. Are you being safe? What are the things you could be exposed to that you may not know? And so this brings us back to the original UL and Georgia Tech research from 2018. And it was in 2015, the nonprofit safety science company Underwriters Laboratory and the Chemical Research Initiative, the Georgia Institute of Technology, Emory University Rollins School of Public Health, they worked together to conduct a 2-year study on desktop 3D printer emissions. And before that, there was really nothing. There was a lot of speculation of how safe people actually were. And over the course of the study, Dr. Marilyn Black, the Vice President, Senior Technical Advisor at UL, and the rest of the team found that the 3D printer emissions can actually pose a potential health threat. And so if we, the paper here, characterization of volatile organic compound emissions for consumer level extrusion 3D printers. The research paper goes into extreme depth, but we'll simplify it for you. Some of the key takeaways that came from this is that more than 90% of the particles that were emitted by 3D printers are in nanoparticle range, so less than 0.1 microns. And when inhaled, can cause cardiovascular and pulmonary issues. There were 200 plus VOCs detected and many known irritants and carcinogens, formaldehyde, styrene, caprolactam, and a bunch of others. And they were in some of the most commonly used 3D printer materials, which, especially for a lot of the people with the desktop 3D printing abilities, came to a surprise. ABS, everyone could smell that. So that one doesn't come as a surprise. Styrene and formaldehyde. PLA, which was touted as an education standard. They were being used in schools and homes. Smells kind of like sweet corn. But it had formaldehyde, caprolactam, styrene. So not as safe as we all really thought. And it's great that this study was out there. And it's kind of the crux of where Rize started and what its mission was about, to pioneer safe 3D printing. Nylon, HIPS, PVA, all of these have these various emissions that are just not safe. And this is during the printing process. And so some of the things that can happen just from a short-term perspective, headaches, nose, throat, eyes, inflammation, coughing, painful breathing, pneumonia, bronchitis, and skin irritation. On this image on the left here is from airthings.com. But the long-term effects, nervous system, headache and anxiety, cardiovascular diseases, respiratory diseases, impacts on your liver, and impacts on our reproductive system. So the big thing was that nobody really knew this was happening. And there are obviously some serious effects if you don't take it seriously. Again, the HEPA filters were being used originally, especially from a particulate perspective, but they had no effect on the VOCs. So really, when you're going out to buy a 3D printer, you really have to think about and make sure that 3D printer has been certified. And if it hasn't, you have to go through that whole process to make sure that it's actually safe for the people using it. And if you're a company, or even in today's world, if you're trying to enable engineers, you want to make sure that it's safe. And so to touch a little bit on Rize, the whole reason we're able to pioneer in this safe space for 3D printing is because our whole platform is designed around this material science platform. So you can see on the left, the actual 3D printing platform is based around augmented polymer deposition, APD. Here we have the Rize 1, and you can see over here we're building a raft to help build a nice level surface for the parts to be printed on. We're adding our release ink to that raft and then building the part on top of that. One of the magic things that Rize is able to do is actually infuse the materials that we use, the Rizium cycloolefin based composite, and we're able to inject the ink almost like adding dye to a t-shirt. We're able to infuse the part with the color at a voxel level, at the smallest levels that you can, and then we're sealing it off with that same material so that it's able to not only have vibrant full color, but that color is secure and sealed, and you're able to reap the benefits of the material science and all the abilities that that plastic has. And this platform not only goes from the materials itself, but it goes to the functional inks as well. And I can actually show you some of these here. So we have Rize 1. So this is the release ink here. We have yellow, cyan, magenta, and black. And these easily get stored into the printer, and these inks themselves are safe to deal with. And we'll touch more on that, on the specifics of what we've done to certify that all of this is safe to use, and that I can have it in my basement here. So one of the stories behind what this whole thing has allowed us to do, which is to adapt to the most extreme situation, which is what has happened with the world today with COVID-19. So back in March of this year, March 16th, we went from working into an office to having to switch to working at home. And so we were able to basically comfortably put our machines into our engineers' homes. You can see here, one of our engineers with their kids and Rize 1 in their home. And amazingly, we all thought it wouldn't have lasted as long, but it is still today, and may potentially change the way that we do work. As you can see, to today we're still doing it, and you can see myself here with the X-Rize and the 2XC there on the middle. And it's really changed the way that we've looked at businesses and being able to enable engineers. And I just feel lucky and honored to have these in my home, to be able to keep staying productive and just enabling me to keep developing at home and keeping the company alive and running. And we're able to help our customers out and keep moving on. And it's really changed the way that we've done everything, right? As you can see here, our CTO, Eugene, completely changed his home office. This is his gym. So he's got both printers set up in his home right next to where he's working out. And from a health and safety perspective, we're able to have that confidence because of the fact that we start primarily as a material science company. So because everything that we're using in the printing process, it's a beautiful view, right? Everything in the printing process that we're using is safe. We're able to put it right next to where you're living, which is an incredible thing and not something that everyone can do safely. The next stage of the 4-part process, the life of a 3D printed part, is post-processing. Before I get into this, we'll go back to, from my experience with ABS, which I no longer print with at home. Most of that was obviously due to the smell, but not only the emissions after finding out that study. But once you print that part, one of the things that ABS was good for was being able to use chemicals to bond and seal. This is 2 parts here. You can see it was bonded and sealed together. But using those chemicals is not safe, and the printing of those parts is not safe. And it just adds extra added process to something that could be a lot simpler. And so when you are trying to get that part from the printing process to being used in real life, the clock starts, and it's a whole bunch of time and effort. And that's really the value that you're playing here, and how much safety is going to be involved between removing supports, whether they're similar materials, just like typical FDM printing, or you're using soluble supports. Both of those have different levels of not only time and effort, but safety and the potential health of that employee behind that. And then, of course, there's surface finishing, right? So there's smoothing supported surfaces, because not all surfaces on 3D printing can be necessarily the same surface finish. You may want to go in and smooth it afterwards. And what you're trying to do is achieve a uniform surface finish, because when most people think plastic parts, they're thinking injection molded parts. That is where their perspective is coming from. So everyone's always trying to smooth surfaces, but how much is going into that? And so if we look at this, we're talking about post-processing, right? So in this specific example, we're talking about soluble supports. A great idea, but the real question is it safe for the operator? And one of the things that Rize helps to achieve a safe post-processing and essentially minimal to zero post-processing is the non-toxic release ink that allows us to remove supports easily and reduce the entire time. So you can see in this video here, on the left, you have Rize. This part was printed on Rize 1 using the same Release 1 ink that's available on the X-Rize and the Rize 1. You can see just how easy it was for the supports to be removed. The surface finish is almost identical to the rest of the surfaces. With the FDM part, you're having to take multiple trips to this bath to reduce the support material. And after 3 hours of going back and forth, putting gloves on, putting a respirator on, and making sure that you're safe, in 25 seconds, you're able to take the supports off of the part made on Rize. So a big reduction in the amount of safety that you have to do. You wouldn't have to go into the office or set up a different area in your home if you have a 3D printed home to make this happen. And then post-processing, removing supports, it's work, it's strain. As you'll see on the example on the right on this video here, I'm a hobbyist printer at heart, so most of my material is the same material for the supports, and it is a lot of time. It's a big effort. It's really strain, and really, at the end of the day, do you want to be spending all that extra time? Here you can see the 3 parts on the left on Rize are going to be processed in just under a minute. That's real time. On the part on the right is a regular FDM. I'm going to speed it up here so that you can actually see how long it takes if you're at all new to it. And if you are familiar with this, forgive the trauma that you may be experiencing right now. Believe me, I've been there. And really the part on the right, that complex curved shape, is a really great example of the extra work that goes into this part processing for typical FDM. So let's say you get the material off and you're able to get that surface. That one surface is not as smooth as you would like. So you're going to have to go and do an additional sanding step, which means you're going to have to put a respirator on. You're going to have to make sure that you're not doing this in the home to bring that into your family or for yourself. So it really begs the question of, is that worth it if we can just take an approach like we do with Rize? We're able to have that releasing, get uniform surfaces, complex surfaces, and minimize not only the amount of work and strain an employee has to do to get that part to be successful, but we're all happier. We're not using PPE. We're not putting people's safety at risk. And of course, this third step is where everyone wants to get to. And everything else up to here is to get to this point where we actually able to use these parts. We're able to 3D print them and use them. We have obviously a story to discuss from a PPE perspective. Anyone that's in the 3D printing world has probably 3D printed a mask or a face shield at some point, maybe a door holder, as you can see there in the middle. But really, there's so much that goes into what part usage and safety and things you have to consider once you get there. So first of all, is the part ready to use after it's printed, right? So we just discussed the post-processing. Is there anything else you have to do? Are there other chemicals you have to be using? Is there some kind of a rinse bath you need to use? How many uses am I getting out of that part? So great, I've made a part, but how often do I have to do this? How many more times do I have to expose myself to those post-processing procedures to make another part to be used? Will my part survive falling off the table? I think this is kind of the crux of early color 3D printing, and still today is great. I have a full color part, but if it falls off the table, is it destroyed? Will my part absorb moisture over time? This is something that many materials, especially typical FDM materials, they absorb moisture, even PLA, they all do, and once it's in there, you've got to get rid of it. And if you have color parts, how long is that color going to last? Is it just a simple thing that once it's on there and it degrades and it really only lasts a certain amount of time? Does that decrease the amount of usage that you get out of that part? And this is maybe a strange question, but are you comfortable eating near your 3D printed parts? The reason I bring this up is kind of what the old world used to be like, where you'd be working in an office, you'd be having lunch with other people, or you'd be having meetings with customers and potential clients, and or even internally where you've got 3D printed prototypes. Could you bring that part into a meeting, pass it around, and be comfortable during a lunch meeting when sometimes that's when you have to work through lunch? Are you comfortable actually doing that? Or is everyone going to have to take an extra precaution to make sure that once they touch the part, they don't touch their food and potentially ingest something that's not safe for them? And then, of course, today's world, and definitely in the medical world, can the parts be sterilized? I know from a 3D printing PPE perspective, I was doing it on my hobby level printers here, And one of the reasons hospitals weren't taking the parts we were trying to donate was because they weren't sterilizable. And that's a big issue, especially in today's world. And then finally, the colored inks themselves, are they safe to use? So let's get into this. So we got to ask, who cares about safety? Everyone cares about safety. It seems like an obvious thing, but we have to say it. And that's everyone from the functional manager all the way down to the end user and the companies themselves. People want to make sure that their people are cared for, that they're safe. The functional manager may be looking at faster innovation with 3D printing at the point of consumption. So having a 3D printer in the office, in today's world, it could be at the home to keep everything moving. But is that safe, and is that going to be a dead stop for this technology going into the business? Sustainability and safety compliance, obviously they will be very they will be asking to make sure this is right. Purchasing manager, NHS for schools, is it safe for kids to be around? Is it safe for the teachers? Is this a place where kids can go in and do their research, develop their products, have an extra added level to their research and projects without having to worry, and parents having to worry about what their kids are doing at school? And then, of course, from the end user, making sure that you're safe. Whether you're working on the printer right next to it or operating it, are you safe? So let's discuss personal PPE. So obviously, our healthcare professionals have been heroes in this. They're on the front lines of all of this. If anyone's been involved in the 3D printing world, you've seen some face shield of some kind. We did our own, and we also did our door holders. You can see on the right there. And it really did make a big difference, especially since our material specifically is sterilizable. The Rizium base for the material has the ability to be sterilized by gamma and ETO processes. We'll talk about this again, but autoclave sterilization won't work just because the material can't handle those kind of heats, even though that may be a simple way to do it. It is definitely something that something to work on in the future, but no other processes are going to be able to give you the gamma and ETO sterilization opportunity that you may get. So the Rize face shields, just to touch on this quickly, if there is an article that you can read about it, but the thing we want to touch on here is that it's a quote from Dr. Rafat Padaria, cardiologist at Cardiovascular Medicine. He said, the Rize shields are very easy to wear, light on the head, they have a great fit, and thin enough for us to look through without compromising our safety. And you can learn more by going to our website and going to rise3d.com/COVID-19-response. There's a great article and a video of our fellow employee David, who's going through the actual creating of those face shields. Now, part usage. We're going through this again. Again, we're talking about the material science platform. These materials are based around the Rizium 1 is based around the USP Class 6 certification. Now, we will touch on that more, but essentially all of the materials, the entire series of Rizium materials from Rizium 1, Rizium Carbon, Rizium GF, all of them are going to benefit from the same material science that Rizium 1 has, with the exception of the composites, who are now going to have some added strength to go along with it. So you're going to get moisture resistance. The Rizium-based material has low moisture absorption, less than 0.01%. So you don't need to store this material any specifically, any type of specific temperature or environment. And even if you're in an environment with a lot of humidity, you're not going to have to worry about your parts and your materials being stored. You also have a chemical resistance. So let's say you're working in a lab or in some type of environment where you're going to be dealing with acids, bases, polar solvents like acetone. These are things that you're going to be able to use your parts safely without worrying about them breaking down. The only thing with this material series is hydrocarbons and long exposure there. Want to avoid that. But you'll also gain UV resistance and, of course, like we mentioned, some sterilization abilities. So let's talk about the USP Class 6, because many of you may not know what that is, and anyone that's in the medical field will know. But essentially, we're talking about non-toxic, biocompatible, medical-grade materials. So pharmaceuticals, medical devices, food and beverage companies, basically anything that's going to be dealing with the human body. Is that material safe? And there's testing that's gone into that. So we've done the work to classify Rizium 1 and Rize 1 and the ink and the inks that we use to go through this testing. And there's acute system toxicity that measures the human hazard by oral, dermal, skin inhalation, intracutaneous reactivity, so the material directly applied to the tissues with no skin protection, so like the face masks, right? And then there's muscle implantation, where it actually goes into the body. So this is a very rigorous testing, but Rize 1 was able to get certified. Again, both of the inks and the material as well. And the different applications for Rizium 1, medical and food industry, and of course pharmaceutical companies, medical device manufacturers, and many more. And the other thing for part usage, and it kind of ties into the printing process itself, but the UL Green Guard 2904 certification, which that 2018 research that we discussed at the beginning, this is what led the UL Green Guard certification. And Rize 1 was the first 3D printer, is the first company in the world to receive the 2904 Green Guard certification for the Rize 1 3D printing system. And it not only met, but it exceeded those requirements because we have such a strong focus on the material science itself. So because we had this strong focus in the beginning, we're able to benefit by being so far ahead of everybody else because we thought about this from the beginning. And then kind of our last topic here, and we'll get into the Q&A, but the end of life of a part. So, okay, you've printed the part, you've used it maybe once, but what happens after a few uses? Am I able to use that part again? I've seen with some of the color printing from some of my fellow employees who used to work at some of the companies that are kind of big in this now. Those old materials, after maybe a year or so, those, and even 6 months sometimes, those resins will start to sweat and degas because of age. They're going to absorb moisture and they're going to degrade. And then even just reuse, let's say you need to extend the life of your part, especially in today's world with COVID. Are you going to be able to sterilize it? And then if you need to be disposing it, can you at all? If there are unsafe inks, even though that resin possibly could be recycled, with that ink, it won't be able to. But any of our color parts or just simple Rizium-based materials are able to be recycled in the number 7 bin, and you're able to do that with ease, not having to worry about where it's going to end up. And of course, just the ability that Rizium gives you is to extend the part end of life with chemical resistance, UV resistance to keep that color nice and strong and vibrant, moisture resistance, and sterilization. And that does it for me. What I'll do is we'll open up the chat here. Thank you guys for joining us and learning a little bit about being safe and healthy with the 3D printing process. Open up the chat here. So one of the things I'll do right now is show you, this is one of our new parts that, let me make sure I got the screen here so you can see. Okay, that's not working. Okay, so here you go. So this is one of our sample parts here. As you can see, we added the QR code here and the full vibrant color. We've got this wood grain that's working completely nice and full color, and we even have color on the bottom here. So what I'll do is I'll take off, let's see, nice, easily. I'm don't even need to use tools in this case. Comes off nice and easy, no drooling of ink on this wrap itself. And here we have our part. So what I'm going to do, these were built without support, so they freely spin, and you can see full color on the bottom. We have build data here. The base itself is built on Rize, and then we have our carbon material and our carbon material and our glass fiber material here. These are our gears. And so these, and this here is our support material. Again, all based on the material science. So regardless of what system you use, you can ensure that everything is based on certified material. And essentially what happens here, we put this gear here. Find the keyway. And there you have it. And so these can be cranked out from my own home using full color, and being able to do things like part marking and QR codes to add extra intelligence to your parts. You can do it safely without having to worry what's going to happen. So I'll leave the chat open a little bit longer, but what I do want to do is thank everybody for coming. One of the things, okay, so one of the questions we have here, are the glass fiber and the carbon materials safe if you use color with them? So yes. Regardless of the fact that they have the glass fibers, they're all based on that Rizium material. So what that's going to do is it's only going to add to everything else. You're going to get everything that you get with the Rizium 1 material. You're going to get added straight with the carbon fibers, and then the inks themselves are safe, so you can get a full color functional part without having to worry about safety. All right, folks, we are at 2:31, so I'll wait another second here just to see if there's any other questions. Other than that, I hope you've had a great day. Thank you for joining us. Don't forget to check out Rize3D.com for everything that we are doing. Our homepage has updates, new webinars are going to be coming out. We also have our YouTube page where you can check out. We had the unboxing of the 2XC, so if you want to see that. We also have promo videos for the 2XC and the future upcoming 7XC. Larger platform for industrial 3D printing. Again, all based on the material science infrastructure that Rize is offering. I can definitely say it's come a long way since 5 years ago when ABS was one of the top materials that was being used around, and the things you'd have to do just to get a part to be printed. The future's looking good and a lot safer, and I'm very proud to be a part of Rize, who's pioneering this effort. Thank you for joining us, everybody. Again, I really appreciate you joining us. We'll see you next week for another webinar. And if you're interested, you have any other questions, feel free to reach out at applications@rize3d.com. I'm Alex Rafanos. Have a great rest of your day.